Hello everyone, good morning. Are you able to hear me?
Yes, Venkat.
Okay. Okay, so let me share my screen quickly. Yeah. So yesterday we have discussed what are RDDs and how to create them, right? And we have seen few transformations as well on RTDs yesterday, right? So today we will see few more transformations, which are few important transformations we'll see today. Along with the transformations, we'll see actions also. Okay, so we'll see remaining actions that we have in Spark RTDs or Spark Core, and then we will move on to the script level or else application level execution, how we will deploy a application to the data proc, right? So we'll see that as well. Okay, so let's quickly jump into that clusters. Okay, so I have this cluster and I'll just start this cluster. So if you're practicing, please try to delete your cluster or else stop the cluster. If you keep your cluster on running state, it will charge and then it will exhaust your free credits. Okay. So I will start my notebook also. Okay. So how many of you practiced yesterday's content? Bablu?
Yeah, Venkat, but the cluster was not created. It was coming showing error.
Okay. Why it was not created?
It was showing error. Let me tell. I will.
Yeah. Please share your screen and
Venki, I got the same issue.
okay. So what issue it is? I mean, okay. So you tried to create the cluster and you're getting error. What is that error? I just want to see that.
Yeah, I'm sharing the screen.
Can you share your screens and tell me what is that?
Are you able to see my screen?
Pablo, your audio is not
Yeah, yeah.
available.
Yeah, you are on mute, Bablu.
Yeah, are you able to see my screen now?
Yes, yes.
Yeah. Yeah, this like this error is coming.
Okay, so what is this error? Invalid argument. Means your syntax is not correct, or else insufficient CPU's quota. Requested 6.0, available 2.0. The resource exceeds your available quota. So it was clearly saying, right? See, there was already a cluster created. Okay,
Yeah.
try to create another cluster, and which where you don't have quota for your project because your project itself is a free credit project, right?
Okay.
So you have only 6 cores available,
Okay.
and there was already a cluster running in. So you can
Okay.
go back to the data proc and check the clusters. So there was one cluster that got created, right?
Yeah.
So if there is already a cluster running in, please try to utilize that cluster instead of creating a new cluster. Okay, so that
Okay.
is one thing. That is the reason of this issue.
Yeah. Yeah, actually, this error I found it in this error. They're telling 50 GB disk size is there.
Hmm.
We need to reduce that. I tried in that also, and I
No,
changed this worker nodes.
no. You see, it was clearly saying, right, insufficient CPU's quota. You just read the message.
Okay.
Requested 6, available 2.
2.0.
So your CPU cores are exhausted. See, you have already a data proc cluster running in with 6 cores, or else 3 node cluster you are doing, and N1 standard 2. That means 2 cores you will be having per machine. So you are already using 6 cores, but
Oh,
for a free credit project you will get only 8 cores.
okay. Okay.
That is the reason uh, it was saying insufficient CPU's quota. You can go to your data proc clusters and check the cluster size. So it is already occupied 6 cores. So I think that is the reason. It is not related to machine types, or it is not related to your uh, other issues. So it is related to your CPU's quota, wherein your existing CPUs got exhausted, and you're trying to ask more, which is not recommended for a free credit project. So in any real time projects, yes, you will be having very good budget, and then they will allocate you good course, but it's a free credit project, so you will have only 8 course limit.
Okay. Okay.
Okay,
Okay. Okay.
fine. So before, if you get this error, try to check whether you have an existing Dataproc cluster in the project or not. Okay, if it is
Okay.
already there, try to utilize that. If it is not working, delete it and then recreate. Okay.
Okay. Okay.
Yeah. Any other issues, Anusha?
Mine is different, Venki. I'm
Yeah.
sharing.
Share your screen.
Yeah, is it visible, Venki?
Yes.
Yeah, got this error. Sorry, I just
Okay.
tried with two accounts. One is this comedy and show 2201. I just activate this one. Whether I activated this account also, I'm getting the same error.
Okay, so you have given the service account as this. Okay, so can you give gcloud config list?
Okay.
Can you type this command, gcloud space config space list?
I got two active things.
Two active things. No, right? Only one is account equals to your username
Yeah,
is there. Yeah.
once.
So
Yeah.
can you set it, gcloud config set, gcloud config set, gcloud space config space set account. No, small set account space. No, your service account. Your notebook always should
Okay.
Point to your service
Yeah,
account.
okay.
No.
Sorry. Yeah.
Okay. Can you execute G Cloud config list again?
Okay.
Okay. Now run the create command.
Okay. Yeah.
Authorized request this command authorized is the active account specified by the account property. Permission denied. Dev DE training. No, Anusha, what is your project name?
One second, Venki. Dev DE training.
That is the command that I have
Sorry,
shared. You have to edit
I
your.
just missed it. Okay. DE training dev. Sorry.
Yeah, you need to change your service account
Yes,
also. Go
yes.
to your Vertex A
I
notebook and
just,
then check your service account.
yes.
That is for my project, not for your all the projects, right?
Yeah, I
So you
just
need
changed
to.
the bucket name, but I forgot to change the project.
Hmm. Okay. Change it and run it and let me
Okay.
know. Okay. Yeah.
Okay.
Okay. So, Prakati, did you get a chance to practice yesterday's
No,
transformations? Okay. Sai,
yeah, so I didn't get a chance to look into it. I'll be looking it today.
okay, okay, fine.
I'm sorry.
Sai Teja, Sai
Uh,
Teja.
Hi, Venki. So I didn't get a chance to.
Okay, okay, fine. Ranganath,
Going to.
okay, okay, fine. So, it's okay. So when you get some time, try to start. You know, practicing in Dataproc, guys. So do things. Get your hands dirty with Dataproc. Explode. Okay. So fine. So let me quickly start sharing my screen. Okay. Hope you're able to see my screen.
Yes, sir.
Yes.
Yeah. So now my Vertex AI notebook as well as my cluster is up and running fine. Okay. So let's quickly go to my cluster and then we will start looking at our remaining transformations and actions in Spark Core. Okay. So today we will also discuss about shared variables in Spark. Okay. So that is one concept that is there in Spark Core. Okay. So we will try to understand that concept as well. So let's quickly jump into that web interfaces and then Jupyter Lab. Okay, so if you see, this is our notebook that we are practicing yesterday. So yesterday we have seen the text file method, and then till where we have seen parallelize, and then map, flat map we have seen, and then distinct we have seen, and then Cartesian we have seen, coalesce we have seen, right? So till coalesce we have seen, correct?
Yes.
Okay. Yeah. So today we will start with the group by key. Okay. So group by key is one of the transformation in Spark core. So this is actually a transformation which triggers the shuffle. Okay. So shuffle meaning. So let me quickly explain. So in Spark, it is very important to understand what is shuffle. Okay. So okay, so when you have all the executors, right? So let us take an example. This is worker node 1, and here I have executor 1. Okay, and this executor is handling partition 1, partition 2 of my input data. Okay, similarly, I have worker node 2. Okay, I have worker node 2, and then I have partition 3, partition 4 of my input data. Okay, and then similarly I have worker node 3, this is executor 2, and then worker node 3, and then executor 3, and then I have P5 and P6, partition 5 and partition 6. Okay, so assume this is the case of my uh, Spark framework. Okay, now I have my driver service which is running here, and then I have 3 workers, and in the 3 workers I have 3 executors that are running in, and out of which each executor is running on a partition. Okay, so specific partitions. Now when you say group by key, right, so what will happen? It will shuffle the data, right, between the workers or between the executors. Okay, it will shuffle the data between the executors. Okay, meaning this P1 P2 will be shuffled to this node, or P3 P4 will be shuffled to this node. Again P3 P4 will be shuffled to P1 P2 P3 P4 will be shuffled to this node. So there will be lot of data shuffle will happen between the executors. Okay, so that is why the shuffle operation is the costly operation in Spark. Be very, very clear. Okay, so when you trigger few transformations, the shuffle will happen. Okay, the data shuffling will happen, meaning the shuffle between the executors will happen. The data movement between the executors will happen. So when it happens, there will be a lot of time and lot of network IO will occur. So this reason will reduce your Spark job performance. Be very, very clear. Okay, so this particular shuffle thing will reduce your Spark job performance, but we have a lot of optimization techniques that we need to do. We'll discuss them, no issues. But the thing is, you need to understand a shuffle is the costly operation, and when you're doing shuffle, what activities that you need to do, you need to be very careful about it. Okay, so if it is with small data, no issues. But if it is very huge data and you have very huge number of partitions, and if it is shuffling, right, so then you need to adjust your shuffle partitions. So that is something that a property that you need to configure. So that we will discuss when we are discussing the Spark configurations. Okay, but remember the group by key, reduce by key, join. So these are the transformations which triggers the shuffle in Spark core. Okay, which triggers the shuffle in Spark core. Be very, very clear. Okay, group by key, reduce by key, and join. Okay, and remaining map, a flat map, a filter. So these transformations doesn't trigger any shuffle. So they can directly go and then work on the each partition, and then they can give the result. But if you want to group your data set, because your data is splitted across all the workers, you have to shuffle it and then only you can group it, because you don't know. Here in the partition 1 you have department id 10 is there. Similarly partition 3 department id 10 is there. So what will happen if you group? You need to get these partitions to one place so that it can group. Otherwise it is not possible, right? Because those are individual machines. Okay, so that is the reason it requires a shuffle when you are using grouping and then aggregating. So these kind of functions, it requires shuffling the data. Okay, guys, are we clear? Are we clear on what is shuffle?
Yes, Venky.
Yes.
Yes.
Okay, just give me a minute, guys. Okay, so fine, sorry. So let's see, the transformations, the remaining transformations, group by key and reduce by key transformations, and then let's understand how they are working in. Okay, so when you want to group a RDD, right? So based on a key, so you can always use group by key transformation. Okay, you can always use group by key transformation along with your map values. Okay, along with your map values. So what will happen now? So here, this is what your input data. Okay, so list of tuples, and then a1, b2, a3, b4. See here, I have duplicated key. Okay, and then I can, it may be department number, salary, right? So you can have anything in this place, but in my example I have taken a, b as a attributes. Okay, so here if you see, for a I have value 1 and value 3, for b I have value 2 and value 4. Okay, so I want to group based on these values. Okay, a and b. Okay, so in that case what I need to do, the first step is create the RDD and then use RDD dot group by key transformation and map values of a list. That means I'm trying to group based on the keys and map these values into a list. Okay, so that I can get the output like this. Okay, I can get the output like this. So it is grouped based on the key, and the values I just map to list. Okay, so you can actually use this function when you are doing grouping operations. Okay, when you are doing grouping operations. Okay, so if you want to simply sum this out, you can quickly use map transformation on top of this grouped data set, and then take the second position and then try to sum up all the values in the list, so that you will get the sum, right? So that is one way of doing your aggregation on a grouped data set. Okay, so the second and the next transformation that we are going to see is a reduce by key. Okay, so reduce by key is also a transformation in a Spark core, which is actually to do the aggregation. Okay, to do the aggregation. So meaning, if you see here, you can actually do the aggregation directly by using the reduce by key on a group data set. So here, if you see, you have a1, b2, a3, b4, and once you use reduce by key, what it will do, it will group, and then it will do the aggregation for you. Okay, so let me quickly run it and see. Yeah, If you see here, it, it has directly done the aggregation on a grouped set. So here your reduce by key, what it will do, it will group and then it will aggregate also. But your group by key will only group, it won't do any aggregation. Okay, later on you have to do the aggregation. Okay, later on you have to perform the aggregation. So if you want a group uh, grouped and then aggregation, then you need to go for reduce by key. Okay, so this reduce by key, if you see the usage, RDD dot reduce by key lambda x. So we have used lambda x comma y. So here if you see a comma 1, so it will take the two values, and then it will sum the x plus y, meaning it will take the aggregated results. Sorry, it will take the grouped results, guys. So it won't take the actual values. So it will take the grouped results, and then it will sum up. Okay, so we will see the execution of this reduce by key in detail, and then group by key also. Okay, so understand, instead of using group by key, always using reduce by key will give you the more performance. Be very very clear. The reason being, in the reduce by key you will be having less shuffle. Okay, you will be having less shuffle, and in the group by key you will be having more shuffle, full shuffle we'll call it as. Okay, but in reduce by key you will be having half shuffle. Okay, so let us understand that how it works. Okay, so now here if you see, I have same worker 1 and worker 2. Okay, for simplicity I will try to so here if you see, in the partition 1 I have department number 10. Okay, and then I have 200, and here department number 10, and then 300, and then department number 20, and then 300, department number 20, and then 400. Okay, so now similarly in executor 2 I have partition 2. Okay, and here I have 10, 100, and then 20, 300. Okay, and then 30, 100. Okay, so if you have data like this, right? So if you have data like this, your group by key transformation, will shuffle all the data. Okay, will shuffle all the data across these nodes or across these executors. Okay, across these executors. So it won't do any kind of aggregation as such. So what it will do is, it will shuffle every record from here to here. Okay, it will shuffle between the nodes, it will move the data between the nodes. So because of that reason, your group by key will trigger full shuffle. Okay, your group by key will trigger full shuffle. Okay, but your reduce by key, what it will do, it will group the data for each executor. Okay, meaning in this executor 1, so or else in this particular worker machine 1, so what are it will do the internal shuffle first, or internal aggregation first. So what are all the departments that I have? Okay, what are all the departments that I have, and group, and then the sum. Okay, and then the sum. So what is the sum? 10 comma 10 comma. Okay, so the sum is 10 comma 500. Okay, and then 20 comma 700. Okay, now it will have its own aggregation for this particular node. Okay, and then similarly it will be having its own aggregation here. So for 10 I have 100, and then for 20 I have 300, and then for 30 I have 100. Okay, so now it will shuffle this data, okay, now what will happen? So it was already performed aggregation here. and then it is shuffling. So and then what at the end what it will do, it will aggregate these two, okay, 100 and 500. Okay, so that is how the reduce by key will operate. So your group by key will shuffle entire data. Your reduce by key will shuffle half data. That means that half shuffle, it will do the internal shuffle first, and then with respect to the executors and workers, and then it will shuffle between the executors. Okay, so that is the difference between your group by key and reduce by key. Okay, guys, are we clear?
Yeah.
Okay, so we have actually a segregation, guys. So in interviews, most of the people will ask how many types of transformations we have. Okay, how many types of transformations we have in Spark? We have two major types of transformations. So one is narrow transformations. Okay, narrow transformations, and then other one is wide transformations. Okay, narrow transformations and wide transformations. So narrow transformations are map, flat map, filter, union. So these are narrow transformations. Wide transformations are group by key, reduce by key, join. Okay, so remember, narrow transformations are the transformations which does not trigger any shuffle in your Spark cluster. Okay, wide transformations are the transformations which triggers the shuffle in Spark cluster. Be very, very clear. Okay, so we have two major types of transformations in Spark core. One is one is narrow transformations, another one is wide transformations. Narrow transformations will trigger, sorry, will don't trigger any shuffle. Wide transformations will trigger the shuffle. Okay, that is the key difference between narrow and wide transformations. In most of the interviews, people will ask you, okay, group by key is a narrow or wide transformation, reduce by key is a narrow or wide transformation. Okay, so they will twist the question like reduce by key doesn't trigger any shuffle, right? Why you are saying it as narrow transformation? So you have to explain them clearly in a way that, okay, so reduce by key still triggers the shuffle, but it won't trigger the full shuffle. It will trigger the half shuffle in such a way that it will do the pre-aggregation for each executor level and for each worker level, and then it will shuffle the data. So it's going to be half shuffle, but group by key will do the full shuffle. It won't do any kind of internal aggregations. It will do the full shuffle, and then that is the difference. So that's why both comes under wide transformations only. So you need to explain the internals very clearly so that people will understand that you have solid internal uh, understanding. Okay, so that is about group by key versus reduce by key. Okay, group by key versus reduce by key. So here if you see,
Venkat,
I
I'm
have
having a doubt.
yeah, yeah.
So shuffling, you were saying, right? So that means the data will be moved across the tasks executors, or like
Yes,
for
yes, yes.
example, 10,200 mean 10 to 200, 10 300. The
Hmm.
other worker no, worker executor data will be moved to executor one. Like so, all the data whichever we are having in executor two, that will be available in
Yes,
executor one.
yes, yes. So no, not executor one. So remember, when shuffle happens, your entire partitions will be rearranged. Okay, so the thing is there is a concept called shuffle service in Spark. What it will do is, as and when a shuffle is getting triggered, it will do the rearrangement of all the partitions. So all the partitions according to the shuffling condition. Meaning, if you see, if you are grouping based on the 10, what it will do, it will shuffle the partitions, and then it will create the partitions based on your grouping condition, meaning the 10. Okay, so for department ID 10, it will create the partition. Department ID 20, it will create the partition. Department ID 30, it will create the partition. So that's a kind of rearrangement of your partitions when you do shuffling.
Okay, okay, got it.
Yeah. So that is why it will take little bit more time compared to no shuffling, because it has to read all the partitions and it has to shuffle. Okay. So when doing shuffle, there is a concept called shuffle partitions. Okay, that is where we have to optimize the shuffle by tweaking this shuffle partitions configuration. So by default, the shuffle partitions are 200 when the data is getting shuffled. So your default partition size is 200. That means whatever the shuffle you trigger, it will arrange it into 200 partitions. Okay. So the configuration you have to trigger or tweak it if you have more data. Spark.sql.shuffle.partitions. So that's the configuration we need to set. Okay. When you are doing the shuffle operation, you need to tweak this configuration to 300, 500, depending on your records. You can write your custom partitioner also. Okay. So that is what you need to do when you are working with shuffle based operations. Okay. So now your Spark 3.x is pretty much matured, and now it was able to create those shuffle partitions on the fly based on your run statistics. Okay. So that we'll discuss later, but for now, try to understand you have a concept called shuffling. Okay. And there are few transformations which triggers the shuffle, and there are few transformations which does not triggers the shuffle. And the transformations which triggers the shuffle or wide transformations. The transformations which does not triggers the shuffle or narrow transformations. Okay. Shuffle meaning moving the data between the executors, thereby between the workers. Okay. So that is called shuffling. And your group by key will trigger the full shuffle. Your reduce by key transformation will trigger the half shuffle. Okay. Guys, are we clear on these concepts?
Yeah.
Yes, sir.
Okay. Okay. Fine. So let's quickly move on and see the next transformation called join. Okay. So here, if you see, I have two RDDs. One is RDD1, RDD2, and you can apply a join based on this syntax. So RDD1 dot join RDD2, it will automatically treat the first value as your join condition. Okay. So then it will do the join, and then it will group and then give it to you in terms of a tuple. So here, if you see, for b2 comma 4, and then for a1 comma 3, so that's how it will join your RDDs. Okay. So similar to your group by on a single list of tuples. So here, the join on multiple RDDs. If you want to see a grouped set for multiple different RDDs, then you can go for join. Okay. So group by or reduce by will do the aggregation on a single RDD, or group on a single RDD, but your join will perform the grouping on multiple RDDs. Okay. So that is something that you need to understand. So your join transformation, if you see the output, it has given you the grouped data set for B and then for A. But these datas are from multiple RDDs. That is where you utilize your join functionality. Your join is also a wide transformation which triggers the shuffle. Okay. So and it triggers the full shuffle. Remember, it does not trigger any kind of a half shuffle as such. It triggers the full shuffle. Okay. So now let's move on to the keys
Um,
transformation. Yeah.
okay, before that, until uh, this transformation, we have used like spark context, right? So here we have used SC.
Yeah. I mean,
So did we create
the
any?
thing is, the thing
Okay.
is, I'll explain that. So it doesn't mean that you need to use SC. So you can directly go for spark.spark context, because the reason is spark.spark context that we created. Okay, but the moment that you click on this PySpark, okay, it itself will create spark comma SC variables. Okay, the shell itself will create spark comma SC variables. Okay, so because you are on a command line interface, so that it will create them by default. Okay, so instead of using the default one, we try to use the created one in our examples.
Okay.
But this SC is default one. That's it. That's the only difference. You can still use spark.spark context. Okay, or you can use SC. This is the default one actually. Okay, this variable is already created by your PySpark notebook. So that is the reason we were able to utilize it. And you can actually use this also, because your Spark context, your SC variable is this only. So how actually your notebook worked? So they created SC equals to spark.spark context. That's it. So that's how they will
Okay.
create SC. Yeah. Okay, so now that's the difference, and then let's move on to the next transformation called keys. Okay, so here if you see, I have this particular list, and I am giving my partition number as 2. So I'm creating a RDD with this particular data, having 2 partitions. Okay, and then I'm using the map transformation on top of my A RDD, and then what I'm doing, I'm iterating, or else I'm iterating each element from my RDD, and I'm forming a tuple in such a way that length of this particular element and then the element. Okay, so if you see simply, if you see the b dot collect, let's understand how actually we will get. Okay, so this is how I got my data. Okay, so that logic is that only, right? So I'm just iterating each and every element, and then I'm finding the length of my element. So those two things, I need to form a tuple. Okay, so dog length is 3, and then tiger length is 5. So like that, my RDD got created. So once you applied this transformation, it created a new RDD called B. Okay, and from A to B, what is the transformation? It's a map transformation. Okay, so that is the lineage, guys. So in our architecture session, we have discussed about lineage, right? So A is a parent RDD, and then B is a child RDD. If you see, A B got derived from A. Okay, similarly, if you create C with a logic on B, then it will become a chain, right? A B C, B derived from A, C derived from B. So that is a lineage. Okay, lineage means from one RDD to another RDD. Let us assume you lost B RDD, then it will be able to recompute it from A. Okay, so that is the lineage fault tolerance. We call it as fault tolerance. RDD lineage, we call it as. So resilient, the first letter in RDD, resilient meaning fault tolerant. Correct. So how it become fault tolerant? Because it follows the lineage of RDDs. So when it follows the lineage of RDDs, so in between, if any RDD got lost, it can able to compute it back from the parent RDD. Be very, very clear. Okay, so that is what lineage. So fine. So now if you see the map transformation output, and then we can always use the keys transformation on top of your mapped RDD. So if you use keys transformation, so your keys will be this, right? So your length, right? So your length of your x comma x. So the first element from the tuple. So you have list of tuples as RDD. So the first element in each tuple will become the key. Okay. So the keys you got. Okay. So that's the keys transformation. Okay. Now let us understand, there is a transformation called aggregate by key. Aggregate by key. So this is a very important transformation when you want to do the aggregations. Okay, when you want to do the aggregations. So here this aggregate by key will be utilized to sum up or to add values right on top of the RDDs. Okay, so now let's quickly see how actually it will work. So this is my data, input data A1, B2, A3, B4, and A5. Okay. So now I want to sum all the data that I have for each group set, and then I want to count the number of records, how many times this group has came, right? How many elements this sum has happened to. Okay, so that is my requirement. In that case, if you see, I quickly created my RTD. If you want to use aggregate by key transformation, you need three functions. Be very, very clear. Okay, so out of which two are anonymous functions, and one is you need to set a tuple value. Okay, so a zero value we call it as. Okay, so you need to pass these three things to the aggregate by key transformation. Let us see what is each function doing. So zero value is something, the initial start value for your summing. Okay, it's a kind of accumulator. So we will discuss that. But so zero value is a tuple. So we need two outputs, right? One is the sum of each group, and then the number of records for that group. Okay, the number of records for that group. So that is my use case. So for that, I need to keep on summing or incrementing the record, right? So I'm starting my value at 0, 0. Okay, I'm starting my value at 0, 0. That is what the meaning of 0, 0. And then sequence function. So sum the values and count them within each partition. So this is one function that will sum the values for each partition, and then it will combine. So there will be another function called a combine function, which will combine all the outputs from sequence function. Okay, so that is the importance of two functions. Okay, sequence is for each partition and combine is for multiple partitions. So now let us understand the logic. Sequence function. Okay, lambda acc comma value. So the anonymous function will receive two inputs, and then what it will do, it will keep on add that value to the accumulator 0. So this one accumulator of 0, meaning acc of 0, meaning this 0 value. Be very, very clear. Okay, so 0 means 0. Okay, 0 plus value, so value you will get. Okay, and then acc of 1 plus 1, so you are incrementing it. That's a partition level logic, guys. Be very, very clear. Okay, so first you are taking the 0, 0 value and you're passing it to your sequence function. Okay, so now here what we will get, 0 comma 0. Okay, comma value. Okay, so 0 comma 0 comma value. So here the value will be 1. Okay, the value will be 1 for a first. Okay, so now here accumulator of 0 will be 0. Okay, and then plus value will be 1. Okay, for the second iteration, what will happen? For the same key, it will become
3.
1 plus 3, 4, and then 4 plus 5, 9. So that's how it will sum. For each partition level, it will sum. Okay. Similarly, for this combiner function, it will receive two variables. Okay. So assume in our case it's AC1, AC2, and then AC1 of 0 plus AC2 of 0, AC1 of 1 plus AC2 of 1. So meaning what it will do, it will get the tuples from the each partition level aggregations, and then it will sum up all the tuples. Okay, meaning it will combine and then do the sum. So that is what it will do. Okay, so the combiner function will take the input from the sequence function, and then it will do the final aggregation. Okay, it will do the final aggregation. So that is the importance of your combine function. So now when you do this aggregate by key, by passing all these three functions, parallelly this functionality will be executed and then it will give the result. Okay, and then it will give the result. So that is what your aggregate by key transformation. Okay, so your aggregate by key transformation will take three inputs. One is zero or starting position tuple, and then your sequence function which runs on a partition level, and your combiner function which will runs on a different partitions. I mean, which runs from different partitions. Okay, combines the data from the different partitions. Okay, so that is the importance of your aggregate by key transformations. Okay, so here when you see the combine function, it will take only the sum. I mean, it will take only the values, the summed values, and then the counters. So these two only it will take. Okay, these two only it will take. Okay, so for that is what we have, and then we can simply move on to the actions. Okay, we quickly complete all the actions that we have. So today we have seen group by key, reduce by key, and we have seen narrow and wide transformations, and we have seen aggregate by key transformation, and then we will quickly move on to actions in Spark core. So action meaning which returns a result, right? Which returns a result. So here, if you see, collect is an action in Spark. So if you're not triggering any action, so your Spark program doesn't run. Okay, be very clear on that. Okay, so that's why at the end of your Spark program or at the end of your application, you have to trigger an action so that it will start your DAG execution. Okay, it will start your DAG execution. So now starting with collect. So collect we know to see what is there in the RDD. Okay, so collect is okay. So collect is something which will be used to see what is there in the RDD. Okay, so then you have count action. So it will return how many elements are there in that RDD. Okay, how many elements are there in that RDD. So remember, guys, RDD is a data structure. Okay, but internal data structure, it follows the list, right? So it is also a list, and it also holds in the form of elements only. It also holds the data in the form of elements only. So that is why you can always check the RDD count, so that you can find how many elements that you have in the RDD. Okay, and then first is the transformation which will give the first element from the RDD, which will give the first element from the RDD. And then take is something which will take the number of elements that you need. I mean, and it starts with the first element. Okay, and it will return how many number of elements you ask. Okay, so these are all actions, guys. Collect, count, take, first. So these are all actions. Okay, so according to the requirement, if your requirement demands, then you have to use these actions also in your program. Okay, so similarly, you have take sample, right? So take sample is something you can utilize to get the sample of data from your input RDD. So how many elements you need? You need three elements. So you can randomly sample the data. So take sample is a action that we will use to randomly pick few elements from your data collection or else RDD. Okay, so you have 100 elements, then you can pick 50 elements as a sample. Then you can actually use this take sample action. Okay, so I don't think it's required, it's optional. Let's see. Okay. Okay, so it requires this with replacement argument along with the number of sampled elements. Okay, so we need to pass this with replacement for this take sample. Okay, that's a mandate argument. Okay, so now you have reduce. Reduce is a action to sum all the elements in the RDD. For example, you have you have a list of integers as a RDD, and you need to sum up all the elements, right? So you can actually use this reduce action to sum all the elements in a RDD if you have list of integers, right? So that is the advantage of your reduce function. Okay, so now you have fold, right? So sum with fold. So here if you see, you have that RDD, and then you are folding it with summing the all the values using an anonymous function. So you can use reduce or fold. So most of the times we use reduce. Okay, so most of the times we use reduce, sum all the elements with an initial value of 0. So if you want to add some initial value, right? So by using fold it is possible. Okay, by using reduce it is not possible, but by using fold it is possible, right? So if you see here, so it should give only 30, right? Why it's giving 60? Okay, so it is doing the multiplication, right? No. There is no relation, it seems. Okay. Okay, so let's quickly go with 5, and then let's see what is our input RDD. 5 plus 1 6, 6 plus 2 8, 8 plus 3 11, 11 plus 4 15, 15 plus 5 20. It is giving 30. Okay, I'll come back to this transformation action later, guys. Okay, so fold is something which will add the RDD elements with the initial value. Okay, so that is something that you need to understand. And then count by key. So basically this will give you the count of it will return a dictionary with the key and the count. Okay, how many times your particular key got repeated in your collection. So that count it will give. So count by key is a action. Okay, so a few interviews you may face, like aggregate by key and count by key. So which one is the transformation, which one is the action? Okay, so you need to say count by key is an action because it returns the result. Aggregate by key is a transformation because it returns the RDD. Okay, so fine. So for each is another action. So to print each and every element from the RDD. Okay. Um, okay. So I don't know why it is not printing it, but for each is action actually we use to print each element in a RDD. Okay, for each line it will print. Okay, so similarly we have print line in Scala. So similar to that we have this for each in this RDD. Okay, so for each is an action to print each line. Okay, to print each line or each element in the RDD. Okay, so I don't know, somehow it is not working. I may need to change it syntax a bit. We'll see it in our next session. Okay, so that is something that about for each. Okay, the next thing is the most important thing, the action that we use regularly in our projects development is save as text file. Okay, so this is a this is an action. I mean, whatever you are doing the writing, right? So it is also treated as an action in Spark. Okay, the write operation, meaning if you processed, I mean, after your processing, you need to write it to somewhere, right? So that writing will be treated as action. Okay, as action. So here, once all the processing has done, once all the processing has been completed, then you can write your results to a text file. When you can write your results to a text file. So that is why we use this action called save as text file, rdd dot save as text file. So you can write your results to, or you can write the processed RDDs to your text file. So that is the save as text file action. Okay, so these are different transformations and actions, guys. So I request you to go through all these transformations and actions and try to practice them. Okay, so note down the task for tomorrow, guys. So tomorrow you have to perform one task on RDDs. Okay, so you have to perform one task on RDDs. So let us take an example. I have this department ID and then salary. Okay, so 10 comma 300, 2 comma 4, sorry, 10 comma 500, 10 comma 600, 20 comma 300, 20 comma 400, 10 comma 100, 30 comma 500, 40 comma 200, 30 comma 400. Okay, so this is my file, guys. Okay, so let me send it across also. dpt.txt. Okay, also I will remove this extension dpt. Okay, so this is my file. So I will simply upload this into Git. You try to go ahead and download. Okay, so add file, upload. Okay, from the desktop. Okay, so I'm just trying to upload the file here. Okay, so you have department wise salaries. Okay, now the requirement is you need to write a Spark RDD based program, to give the top highest department. Okay, top highest paid department. Okay, so your final RDD should be having a result of only the top highest paid department, which is 10th department or else some other department if it is. Okay, so you need to use your RDD programming knowledge that we have seen till now. It may be aggregate by key, or it may be group by key, reduce by key, whatever you feel it is sufficient. You can use all the actions first, right? So take first, whatever, how you can sort the RDD. So that is something that you need to explore, right? So the thing is, you need to find out the top paid department from this data using the RDD programming. Okay, any questions on the task, guys? Any questions?
No.
Are we clear? Anusha, Prakati,
Yes, sir.
Bablu?
Yes,
Yeah.
yes, sir.
Yeah. So that is the task for you. So try to do practice, guys. So it is important to practice. Otherwise, you will forget things very easily. Okay. So that's all I have for today, guys. Tomorrow we will start with shared variables in Spark. Okay. Mostly tomorrow I won't take class because I have a meeting conflict. I have a meeting which is starting at 7:30 till 9. It will go, so I won't be able to connect tomorrow. So we'll connect back on Friday, and this week we'll continue the weekend also, Friday, Saturday, Sunday. So by Sunday we will try to complete everything related to data proc and Spark. Okay, so that is uh, about the update. So tomorrow we don't have any class. Okay, so we have a class on day after tomorrow. Okay, thank you so much for joining once again on Friday.
Thank you, sir.
Thank you.